ladies, here are the answers for your 3.2 homework assignment from yesterday. Just a quick note about these. If you have your answers in a non-factored form, so for example, down here for number 5, if you had 2x minus 4 in the denominator, that is totally fine. It's not any less simplified. However, you don't need to re-multiply things out. The nice thing about not multiplying things out and leaving things in factored form is that then you're sure that you canceled out anything that you could possibly simplify. So go ahead and press pause so that you can check these over. Again, if you need to ask any questions, feel free to do so of both your classmates as well as the teacher. And if there's any continuing outstanding questions, I can answer them when I get back. Today we're going to learn 3.3, which is complex fractions and mixed practice. Basically, by definition, a complex fraction is an expression that contains fractions in its numerator or denominator or both. I'll give you a second to write that down. So you notice in this example, I have a fraction in my numerator as well as a fraction in my denominator. Over here, I have some basic kind of steps for how to best do these. I like to factor everything first. I think that it makes everything look a bit nicer. So I'm going to go ahead and factor this first fraction in the numerator. So I could pull out the numerator of the numerator, if you will. I could pull out a 3, so I'd have 3x or times x minus 4 over 4 times x plus 5. Now that's over the second fraction. I can pull out an x, so I have x over x minus 4 over x times x plus 5. Okay, so notice that everything is factored out. Now, when you have a fraction divided by a fraction, so say like 1/2 divided by 2/3, how we always solve that is that we flip the second fraction, getting the reciprocal, and then we multiply. So this would, another way that I could write this would be 1/2 times 3/2. Okay, notice I took the reciprocal of 2/3 and I changed it to multiplication as opposed to division. Now it's a quick, easy multiply across the top, multiply across the bottom, or multiply the numerators, multiply the denominators, and then simplify. So this would be 3/4. So I'm going to do the same thing with my complex fraction here. If at any time you ever get confused as to what you should do something simple like this so that you can see exactly what you're supposed to do with something more complex. So I'm going to do step 2 now, which is rewrite as the multiplication of 2 fractions. So we're going to rewrite this. I'd still have 3 times the quantity x minus 4 over 4 times the quantity x plus 5. And now I'm going to change this division to multiplication, and I'm going to take the reciprocal of the bottom fraction. So this would be x times x plus 5 over x times x minus 4. Okay, so notice that I changed this complex fraction into the multiplication of 2 fractions. Once you get it to this point, now it's a nice, quick, simple simplifying like we did in the past. So remember, looking at both the numerator and the denominator, we want to cancel out anything that we could divide out to equal 1. So for example, these x's, I have an x in the numerator, I have an x in the denominator. So those can go away. I have an x plus 5 in the numerator and x plus 5 in the denominator. And then an x minus 4 in the numerator, x minus 4 in the denominator. This is totally my favorite part of these lessons because I feel like I'm Zorro and that I get to cross them out. So once you're done canceling out anything that you possibly can. Because it's fully factored, I know that that's as many things as I can cancel out. And so you're left with whatever's in the numerator and the denominator. So I have 3 in my numerator, 4 in my denominator. That would be my final answer. Notice how much this very, very complex fraction was able to simplify down to be. So 3/4. Sometimes the problem involves simplifying the numerator or the denominator before you actually perform the division. So you might have to do a little bit of figuring stuff out with the numerator and the denominator. Notice in this case, I have 3 plus 1 over x. So I don't have just one fraction. I can't flip the 1 over x and assume that it's going to change into multiplication. So what I want to do is I want to create one fraction in the numerator, one fraction in the denominator. So then I can use the steps from the last slide in order to be able to solve this. So again, one fraction in the numerator, one fraction in the denominator. Okay, so that's where my first step kind of comes from. Make each numerator and each denominator one fraction. So I'm going to go ahead and start to do that. Now, in order to do that, I need to make common denominators looking at both my numerator and my denominator. So sometimes I like to break this up. Here's my numerator, here's my denominator. Okay, so I would have 3 plus 1 over x. That's my numerator. So if I want to turn that into one fraction, I need to make common denominators within this numerator. So I could multiply 3 by x over x to get 3 over x plus 3x over x plus 1 over x. So now if I add that, I get 3x plus 1 over x. That is one fraction. Doing the same thing over in my denominator, I have x over 5 minus 2. So notice that I want my denominator to be 5, so I can multiply this by 5 over 5. So I'd have x over 5 minus 10 over 5, or x minus 10 over 5. One fraction from my denominator. So to rewrite this, basically what I just figured out is that I could rewrite this original having issues with my pen. I could write that original to be the same thing as 3x plus 1 over x divided by x minus 10 over 5. Now, if you notice, everything is fully factored. I can't factor anything else out. So now I can use my steps from the last slide that will help me to solve this. So I'm going to rewrite this as a multiplication problem. 3x plus 1 over x times 5 over x plus, minus 10, And now I just multiply. So I have 5 times 3x plus 1 over x times x minus 10. Now, if you wanted to multiply those out, you could. I don't like to because A, it's one extra step. B, if it's in factored form, you absolutely 100% know that there's no other pieces that you can simplify. If it's not in factored form, there might be a factor in there that you're not aware of. So please go ahead and let's start practicing keeping it in this form. Okay, so we're going to do board practice similar to how we did it yesterday. You go up with your groups and do these 4 questions. My hint to you on 2 of these, my hint for person 3 is notice that this is a trinomial, so you'll still need to make all common denominators to create one fraction in the numerator, one fraction in the denominator. My other hint for person number 4 is that notice that you have x squared minus 25 over x minus 5 over 3. X squared minus 25 is kind of like a fraction where you'd have x squared minus 25 over 1. If you think of it that way, then when you look at the top, the numerator, you could look at the numerator as this fraction and then the denominator as this fraction. When you are finished with your board practice, you may go ahead and check your answers. The answers for numbers 1 through 3 are on page 63. It's the self-test answers. And then the answer to number 4 I have written here for you because I just pulled it as another example. So if you need help with that one, feel free to ask the people around you. Homework for today is going to be page 62, set B. When you are finished and you get all the answers correct, feel free to get started on that. Go ahead and press pause at this time and you guys may get to work. Thanks, ladies, and have a great day.